So now we want to learn about X-ray diffraction. So in order to do that, we're going to know what is diffraction. So if you could imagine a room like this, and then there's a door like that, and let's pretend that you're inside the room, and then let's also pretend that there's somebody out here outside the room. And then let's say that they are speaking. So those are the sound waves being emitted by them. You know, you can still hear him or her if you're inside the room. Now you can't see this person because of the wall. So that wall gets in the way, so you can't see them. But you can hear them because these sound waves, when they encounter the door, they spread out like this, and then they go into the room, and then you can hear the sound waves. So this process by which a wave will expand whenever it encounters an opening like that is going to be called diffraction. It's not just sound. Light will do the same thing. So when light encounters an opening, it will also spread out like that. So how can we use this technique in geology? So if you recall, a mineral consists of atoms, and then those atoms are arranged in a lattice so that there's a certain distance between the atoms, and then also there's a certain shape that the atoms make in the lattice. So what we do is we're going to take X-rays, we're going to take light, and we're going to pass it through the crystal. And so whenever the light rays encounter these crystals, they're going to be diffracted a certain amount, and the amount of diffraction is going to depend on the distance between the atoms and also the spatial arrangement of those atoms. So the scattered light, the light that's been diffracted, then goes into a detector, and then that information can go into a computer where it can analyze the pattern made, and then based on the pattern, it can reconstruct what must have been the distance between the atoms and how were the atoms arranged in that particular mineral. So again, this is pretty powerful stuff at the disposal of a geologist. All right, let's look at one more thing in our next segment.